Like, what's the biggest thing I could put for x and still be okay? 3.
Trace.
Because 3 squared is 9, 9 minus 9 is 0. You can do the square root of 0, 0. That's okay. But if you plug in anything bigger than 3, like 4, or 3.1 or whatever, 4 squared is 16, 9 minus 16 is negative, square root of negative is imaginary, so that's no. So x has to remain smaller than 3. What's the smallest thing we could plug in? Negative 3, because negative 3 squared is also 9. You can't plug in negative 4 for the same reason you can't plug in positive 4. They both equal 16. So the domain, so x has to be bigger than negative 3. So the domain is that x can be anywhere from negative 3 to 3.
Is it less than or equal to?
Oh yes, good point. Less than or equal to. It can equal 3. What's the range? You guys remember when you graphed from this one yesterday? So I plugged in 3 and I got 0, so that means 3, 0. I plugged in negative 3, I got 0. I plugged in 0,
Was this the semi?
got 3. So it was like a semi, well, if you could plug in more points, but they'd be like weird square root answers. If you plugged in like, square root of 5 or something, you get 2. So it's kind of hard to graph those. But anyway, it makes a little, you don't really have to know what shape it is, you just have to know it goes up and down like that. So what's the range though? What's the lowest and highest y values? 0 to 3. It's going, starting down at 0, going up to 3. So the range is running from 0 to 3. What are the, we had to kind of answer this for the domain part, but what are the zeros of the function? What makes it equal to 0?
Plus or minus 3.
Yeah, negative 3 and positive 3. Yeah, the one on the test is just a little bit different from that, so if you understand that one well, you should be good. I know that's kind of a weird one. But... Alright, I am hopeful that we will do well on number 2. I'm assuming some people will miss D.
Oh, there was a D?
It was hidden.
Yes, I will miss D.
Oh, I should have done one that actually worked. Well, here, let me fix it.
What? But I already did them all.
No, you didn't.
Yes, I did.
No.
Don't do that. I gotta redo them all.
Gosh, dang it.
Gosh dang it.
Just ruined your life.
We did.
You ruined Sam's good day. I ruined Willow's good day.
I'm looking forward to it.
It's gonna be a highlight of this
It's gonna be like, hey, guess what?
I don't know why I'm evil, I just know that I am. I'm a fallen sinner, I guess. Don't quote me on that. don't put that in the yearbook. Okay, so for A, we just have to, I guess it's on video now. We have to add these two together, but you can only really add the like terms. Suppose if I wrote it out, it would look like this. You don't really need parentheses on this one, but it would be x squared minus 2x plus 1x is negative 1x. And negative 3 plus negative 3 is negative 6. So on b, we're going to subtract those two. Okay, x squared is kind of untouched. Negative 2x minus 1x is negative 3x. Negative 3 minus negative 3, 0. So that,
Oh, you changed the 1 to a 3. My bad.
change a couple things. Okay, what kind of problem? Uh-oh, this might be an issue. What kind of problem is this?
Foil.
Well,
Yeah, it's a foil. Well, it's not exactly a foil this
I
time.
just thought it was like kind of double putting the X in the 3.
It's like a foil, but this has 3 terms, so you can't really use foil. It's probably best way to think of it is like a double distribution problem. So you want to multiply. I like to start. You could do all 3 of these times both of those, but I think it's easier if you think of it like both of these times all 3 of these. Everything needs multiplied by everything in the other one, basically. So this one's actually a little bit harder than what we did yesterday, because yesterday's was a foil. If we multiplied by x, they still get an extra x. That's quite a reaction. If we multiply by negative 3, and then I kind of wrote it so that the like terms were stacked. Not that it matters, but then you add the like terms together. Okay, how did we do division yesterday?
I don't remember.
We did synthetic division. I think it's set up so you could actually use factoring to do this. So if you like factoring, let's see.
I don't think so.
Yeah, it does factor on the
But
test
we don't
too.
know like that.
We use factoring. Okay, you could do synthetic division. You guys know what this
1,
top thing
-2,
factors to?
-2. Oh, we're doing
Okay, you can do synthetic division, but I think factoring is
X
easy.
plus 1, X minus 3.
Right, what multiplies into negative 3, that also adds up to negative 2.
1.
It's 1 and negative 3, yeah. So, they're kind of choosing it so it come out nice like that. So the x minus 3's cancel out x plus 1.
So on the test is going to be factored?
Yeah, I just checked.
Okay.
Number 3, we're actually using the same f of x and g of x.
Timer?
Okay, what does this thing, fog thing mean?
Goes into it.
G goes into the.
Right, we're going to put the g function into the f function, which means we're going to pick this up and put it in for the x's right there. Am I going to make you simplify this? That is the question.
No. Oh, you won't.
I'm not going to make you simplify it.
You won't.
What if I said it's worth a bonus point if you simplify it?
Then I'll simplify it.
1 bonus test point.
He said.
Correctly.
No, great.
Well, x minus 3 squared is a FOIL problem, right?
Right.
But for time's sake, I think I'm just going to keep on rolling. Okay, what's GOF? It's not really an O, it's just a little circle thing. but we're gonna put the f function into the g. So we're gonna pick all this up, imagine me grabbing it, and drop it right here where the x was. So it's just all of that minus 3. Now this one is pretty easy to simplify. It's like all of that minus 3, so it's junction, function.
It's gonna be stuck in my head all day.
Who gonna freeze? Time to get out the graph paper.
You better share this time instead of just one. He never passes it down.
You're all got those nails down.
You just have like 2 papers.
That was one
and I wouldn't have it. I'm like, I didn't get one this week. I was
Straight
straight
up.
up.
Every get out all year.
And you're not a nails person.
Can't believe it.
Sarah did it one time and just showed up.
Okay, that was funny for nails though.
Maybe it was, but you just blamed it on Jared.
You just nail polish though.
Mine is from
It's from what?
home.
Yeah.
I don't know myself.
I could tell. I'm just kidding.
Where?
I'm just kidding.
Oh.
Yeah. Shocking. Okay, let's do
Why are they all? I don't know.
the whole family.
Yes, there are.
And the dog. And the dog. Ricky should leave blue.
I need to go.
It's just 4.
He was like, hey.
Yeah. Okay, we kind of need a graph. Whoops. We need a graph to look at.
Oh.
Periodic. Let's do mountains and valleys or something. Let's do this. That's kind of weird. Okay. You're fired.
You can't erase your mistakes.
I don't like this.
It's not repeating. It's supposed to be repeating, I thought.
Yeah, it is.
Too many. Oh, it is repeating. I just can't see very well.
Yeah, that's all I got. Okay, so the first part, we're gonna do the period thing, but that's number 5. The first part is to graph these things. Where am I gonna put it though? I might have to zoom out.
Repeat every shit.
So if this is f of x, this is the graph of f of x. Then they want us to graph one half of f of x.
Do we have to use different colors?
Now we're gonna do a different graph for each of these.
Oh.
So what happens when you do 1/2 times the function or 2 times the function or whatever?
Grows or
It
shrinks?
changes.
How?
Great, sure.
If you multiply everything by half,
It gets
okay, yeah, all the y values are gonna be half as big, so it's like a vertical squish. So if the value was at like -1 out here, how far is that? 3, 4, 5, 6. It's gonna be at -1/2.
Oh.
So it's only gonna go. Okay, instead of going up to 2 right here, what's gonna happen? It's gonna go up to 1. Alright, the next one is absolute value. What's the absolute value gonna do?
Make it stay above the.
Okay, wherever, so let's look at this one. Wherever it was negative, it's gonna become positive.
Mm.
So at -6, instead of being equal to -1, 1, 2, 3, 4, 5, 6, it's gonna equal +1. Okay, at -5, it's at 0, so it'll still be at 0. And the stuff that was negative is still gonna be positive. Oh, this will look weird. Oh, whoops. Didn't draw that very well.
Oh.
Well, it's kind of hard because this is folding up right here, so it's just gonna look like a bunch of little hills. But this part is staying the same. So what I got so far. It's not a very good graph for flipping.
Catch 2, 4.
Yeah, this is maybe a little bit harder than the one on the test. If you imagine like all this on the bottom folding up, that's what's happening. It's kind of a mess. I don't think the one on the test is quite that messy.
I'm just gonna say that looks right.
Okay, but what I was doing basically is looking at each point. Like this one at -6, -1, I turned to -6, 1. At -5, 0, it just stayed -5, 0. This one stayed the same. This one stayed the same. This one flipped up. This one's kind of weird because it's like at -1 2/3, but I put a dot right there, and that was supposed to be like -1/3. But where it hit the x-axis. Anyways, let's.
Does it just go up to 0 or does it go up to 1?
This, yeah, it went up to. So it's at -1, so it's gonna go up to 1. Because the function value is -1, so when you do absolute value, it just becomes +1. So it just flips it up. Alright, maybe this next one won't be so messy. Negative f of x, if you make the function negative, what's it gonna do?
And switch.
It's what kind of flip?
Horizontal.
Vertical. Okay, all the function values are basically the y values. So when you make the whole function negative, all the y values switch. So it's gonna be upside down. So I just found each point and flipped it upside down. I kind of use the pattern too. I know it goes like up 2 and over 2 and down 2 and back 2. And the last one, D, is just like yesterday's. It's x minus 2 in parentheses. Well, yesterday might have been x plus 2 actually. So how do we do x minus 2?
Just move it down 2, right?
Left to.
Oh, it's in the parentheses.
Okay, if it's directly on the x, you guys remember doing
Right, sure.
this stuff? Like, remember this?
Yeah.
What's the plus 3 do?
Move it up 3.
Makes it go up 3. So if there's like a plus 3 out here, it would go up 3. What's this minus 2 do? Right 2. It's right 2. It moves it left to right, but it does kind of the opposite when it's on the x. But yeah, so the whole thing needs to move right 2. When it's directly on the x, it moves left to right. It affects the x value. So this top thing, instead of starting at like -6, it'll start at -4 if you move right 2. I forgot what it looked like. Really steep.
So
I
if
wonder
it was
if I can.
plus, it would just be left 2 more. Or left 2.
Yeah, plus 2 would be left 2. I think that's the one we did yesterday. Okay. I'm gonna zoom out a lot because I need to see this. We're still referencing this graph right here. Number 5. I think it asks for the period first. What is the fundamental period of the function f?
Do we need to go graph first?
No, we're not. We're using this graph. We're not graphing it.
Okay.
We're not graphing anything.
Okay.
It's.
Amplitude. Okay, what is the period? If I was doing it, I'd probably go mountaintop to mountaintop. So it's 1, 2, 3, 4. There's one right there, 6. Any questions on that? Just how far does it go before it starts repeating itself? You could do like anywhere, but what are the maximum and minimum values? How high does the graph go? 2. How low? -1. So yeah, so it's 2, -1. Goes up to 2, down to -1. The reason they asked that, it's gonna help us set up the amplitude. The amplitude is like half of the height of the graph. So if the graph goes from -1 to 2,
1, 0.
how tall is that from -1 to 2? It's 3 tall. To find the amplitude, you just divide that by 2. So it's 3 over 2, or like 1.5.
Now, where'd you get the, never mind, you got the, you divide by 2.
Okay, I guess we're done with the graph paper. We're actually almost done with the test too. There's a
That
couple
was
more.
a short test.
We got a couple more questions.
Oh,
There's about, if you count like each graph as one, it's like 18 questions. Each answer is one question. Okay. I don't know what number we're on. Are we on 6, maybe? Okay. Does this one look familiar right here?
you,
It's kind of like number 1, right? What shape does that take? Like a semicircle. Is that going to have an inverse?
No.
No.
new.
It fails the horizontal line test. What shape does this one take? A line. Does that have an inverse?
Yes.
Yes, it does. So it's going to be the simpler one. Fortunately, so g of x is kind of the first answer. It has an inverse. And how do we find the inverse? That's really the main part of the problem.
Could you just say like the line thing? Or would you have to put something else?
Which of the two functions, g of x is the function, or you could just say g is the function. How do we find the inverse? Switch the x and the y value. So I replaced g of x with y just to make it easier to work with. And then solve this for y. And then to put it back in function notation, it's just g inverse equals that.
Couldn't it also be 1/3 x and then we have.
Yeah, could also be 1/3 x plus 1/3. Uno mas? We're doing pretty well on time. This is a short test.
No.
Yep, there's one more. I need a name.
Mac.
Why is that?
Mac.
Like,
It was the first thing that came to mind.
I should have asked.
Like the truck from Cars.
Is that how you spell it?
Yeah.
Is that gonna be your firstborn child,
Oh gosh, no.
even if it's a girl?
I feel like you'll name it some Greek name or something.
Oh yeah.
I thought your kid.
How is that a girl's name?
Mac Ellen.
Mac is,
Ever seen Teen Beach Movie? Oh yeah, her name's Mac.
Teen Beach
That's the
Movie.
first thing I thought of.
That's not the Australian thing, is it?
What?
Never mind. I asked,
Oh, you mean the mermaid movie? The
Yeah.
mermaid- No, no.
I asked the girls yesterday.
H2O, just add water.
I asked the girls.
H2O.
No, I asked the girls yesterday where they got the nar from.
You were saying it yesterday.
Like they were saying nar instead of no.
No.
I was like, where did you get that
That show
from?
was so good.
It sounds epically bad.
It's not. It's so good.
I watched the show
You
just
see
for
the
the
accents.
accents.
It's really good.
It's entertaining. I've literally watched the whole show.
I watched it multiple times.
I could totally see Trey just.
That's the only
watching
movie.
it, like-
That's the only movie Trey's watched all the way through.
Yeah.
It's the one.
He was like, it was too good to leave.
Don't act like Cora made you watch it. You wanted to. I was forced.
Corey made me. She held me
Corey
down.
was literally talking about it yesterday in PE.
Corey told me that a couple of years ago you guys were on a trampoline and you like stepped on her hair and a chunk of her hair came out. or something.
I remember that.
She said she was gonna beat you up.
Yeah, she was really mad at me. But it was an accident, so.
She couldn't be.
Yeah.
Unless it was because you did something stupid.
Sounds painful.
It does.
Remember when you pulled a chunk of my hair out? I remember when I was talking to somebody and we pulled my ponytail and I
Too
went
bad
through
you weren't
two rows of seats on the bus.
They got their powers.
You know what I'm talking about?
That was
I
a
flew
crazy-
You guys remember
That was funny.
Warren Bisadecki?
Yeah.
Yeah.
One of his older sisters, his younger older sister. I don't know what it was, but she got her hair like caught in some kind of fan or something, and like yanked the back.
One of those electric tunnels to drain things I like was playing with.
No.
They got caught in Braylee's hair. They kept it just wrapping around her hair.
Isn't Warren Bisadecki in like jail or something?
Yeah, he got arrested.
For
For
what?
what?
Threats.
Threats.
That's not good.
Is he still in jail?
That class
No,
is just
not
cursed.
anymore. He just got charged.
How much did he get charged?
I don't know. That threat is bad.
Probably
The threat
quite a
to shoot
bit.
up a college, that's bad.
I heard it was $500,000.
Who's
That's
bailing him
right.
out?
No,
But
that's,
I didn't think that was
that's
true.
that's like his whole charge.
Yeah.
But he was able to be bailed out for $50,000.
Yeah.
Who has that money?
Probably parents.
So does he just have to pay the rest of her time or?
Just throw a chunk of money and say, hey, here's $500,000.
Alright, you guys remember how to do this one?
Yep.
So how do we average three numbers? Okay, so we got a 75, an 87, and
T.
unknown. Divided by 3.
You just want to
I wanted to T.
If he wants to get at least a B, what?
80
Okay, 80, but what should I put right here?
equal. Wait, no.
Greater than.
Yeah. Good job.
Now, what's the algebra trick we should use?
Times 3.
Times 3, we'll get rid of that. Alright, you could write it out here, I guess. Times 3 gets rid of that. Let's see, what is that one? 62.
Is that it?
Yeah, that's it.